Troubleshooting high neutral to ground voltage requires a systematic approach. The manufacturer specifies less than 2 volts between neutral and ground for proper equipment operation, and you are currently measuring more than 3 volts with no load on a dedicated circuit. Here is a breakdown of potential causes and solutions. Firstly, address grounding issues. Inspect the ground rod connection. Ensure it is properly installed and exhibits low resistance to earth. The ground rod provides a path for fault current to return to the source, helping to trip circuit breakers or fuses in the event of a ground fault. A high resistance connection can impede this process, leading to elevated neutral to ground voltage. Verify that the neutral and ground wires are securely connected to the panel and the equipment. Loose connections can introduce resistance, which contributes to voltage drops and increases the potential difference between neutral and ground. Inspect the circuit for any loose or damaged ground wires. Damaged or corroded ground wires can similarly increase resistance and affect the grounding path. Secondly, investigate the neutral to ground connection. Ensure that only one neutral to ground bond exists in the electrical system. This bond is typically located at the main service entrance. Multiple neutral to ground bonds can create circulating currents, raising the neutral to ground voltage. Remove the neutral to ground bond at the panel if present, unless it is the main service panel. Check for any unintentional neutral to ground connections within the circuit. Faulty switches or outlets could create unintended paths between neutral and ground. These unintended connections can disrupt the proper flow of current and elevate the voltage between neutral and ground. Thirdly, consider load balance, even on a dedicated circuit. Other connected loads within the electrical system can influence the voltage between neutral and ground. Imbalances in the loads connected to different phases can cause current to flow in the neutral conductor, which can contribute to the neutral to ground voltage. Try disconnecting any other loads from the panel and retesting the voltage. This will help determine if other loads are contributing to the issue. Fourthly, check for high resistance in the circuit. Examine the circuit for any loose or corroded connections. Loose connections introduce resistance, leading to voltage drops and increased neutral to ground voltage. Tighten all terminals and connections throughout the circuit. Measure the resistance of the circuit using a multimeter. Elevated resistance can indicate a faulty wire or connection. Compare the measured resistance to expected values to identify any potential issues. Fifthly, assess transient voltages. Fluctuating voltage levels can cause elevated readings. Transient voltages are brief spikes or surges in voltage that can occur due to various factors, such as lightning strikes, switching of inductive loads, or utility grid disturbances. Check the voltage over time and observe if it stabilizes within the manufacturer's specifications. A recording voltmeter or data logger can be useful for capturing transient voltage events. Sixthly, consider the possibility of faulty equipment. The equipment itself might have an internal fault or malfunction that is causing the high voltage. Internal components within the equipment may be shorted or damaged, leading to leakage currents or other issues that affect the neutral to ground voltage. Contact the equipment manufacturer for assistance. They may be able to provide troubleshooting guidance or diagnose the issue with the equipment. Additional tips include utilizing a high impedance voltmeter to measure the voltage between neutral and ground. A high impedance voltmeter minimizes the loading effect in the circuit, providing a more accurate voltage reading. Perform the measurements with the equipment disconnected to isolate the issue. This helps determine if the high voltage is originating from the equipment or from the circuit itself. If the problem persists after trying all of these steps, consider consulting with a qualified electrician to troubleshoot the problem and ensure the safety of the electrical system. Electricians possess the necessary knowledge, skills, and equipment to diagnose and repair electrical issues safely and effectively. Now let's go over the tools needed. Firstly, a multimeter is essential for measuring voltage, resistance, and current. A digital multimeter provides accurate readings and is easy to use. Secondly, a voltage tester is a simple tool for verifying the presence of voltage. It is useful for quickly checking for energized circuits. Thirdly, an insulation resistance tester or megometer is used to measure the insulation resistance of wires and cables. This tool can help identify damage to insulation that may be causing leakage currents. Fourthly, a ground resistance tester is specifically designed to measure the resistance of the ground rod connection. This is important for ensuring that the grounding system is effective. Fifthly, a wire stripper is used to safely remove insulation from wires without damaging the conductors. Sixthly, a screwdriver set is needed for tightening screws and terminals. Use a variety of sizes and types to accommodate different connections. Seventhly, pliers are used for gripping, bending, and cutting wires. Eighthly, a flashlight or headlamp is necessary for working in dark or confined spaces. Ninthly, safety glasses are essential for protecting your eyes from debris. Tenthly, insulated gloves are needed for protecting your hands from electrical shock. And lastly, a non-contact voltage tester is a convenient tool for detecting voltage without making direct contact with conductors. Safety precautions are paramount when working with electrical circuits. Firstly, always turn off the power to the circuit before working on it. Verify that the power is off using a voltage tester. Secondly, never work on live circuits unless absolutely necessary. If you must work on a live circuit, use extreme caution and wear appropriate personal protective equipment. Thirdly, follow all applicable electrical codes and regulations. The National Electrical Code, or NEC, provides guidelines for safe electrical installations. Fourthly, if you are not comfortable working with electrical circuits, consult with a qualified electrician. Fifthly, always use properly insulated tools. Insulated tools provide protection against electrical shock. Sixthly, never work in wet or damp conditions. Water is a conductor of electricity and can increase the risk of electrical shock. Seventhly, be aware of your surroundings and avoid contact with grounded objects. Eighthly, work with a partner whenever possible. In case of an emergency, a partner can provide assistance. Ninthly, use a lockout-tagout system to prevent others from accidentally energizing the circuit while you are working on it. And lastly, if you are unsure about something, ask for help. It is always better to be safe than sorry. Common causes of high neutral to ground voltage include improper grounding, multiple neutral to ground bonds, imbalanced loads, loose connections, and faulty equipment. The grounding system provides a path for fault current to return to the source. An effective grounding system helps to minimize the risk of electrical shock and damage to equipment. Multiple neutral to ground bonds can create circulating currents, which can increase the neutral to ground voltage. Only one neutral to ground bond should be present in the electrical system. Imbalanced loads can cause current to flow in the neutral conductor, which can contribute to the neutral to ground voltage. Distribute loads evenly across the phases to minimize neutral current. Loose connections can introduce resistance, which leads to voltage drops and increase neutral to ground voltage. Tighten all terminals and connections to ensure a good electrical connection. Faulty equipment can have internal faults that cause leakage currents or other issues that affect the neutral to ground voltage. Test the equipment to identify any potential problems. Additional considerations include the impact of nearby electrical equipment. High voltage equipment or other sources of electrical noise can induce voltage in the neutral conductor. Shielding and filtering techniques can help to minimize the impact of electrical noise. The use of surge protection devices can help protect against transient voltage surges that can damage equipment and increase the neutral to ground voltage. Regular maintenance of the electrical system can help prevent problems that can lead to high neutral to ground voltage. Inspect connections, check grounding systems, and test equipment regularly. When measuring neutral to ground voltage, it is important to use a reliable and accurate voltmeter. Ensure that the voltmeter is properly calibrated and that the leads are in good condition. Take measurements at various points in the circuit to identify the source of the high voltage. Compare your measurements to expected values to identify any anomalies. If you are unable to resolve the issue, consult with a qualified electrician. An electrician can perform a thorough inspection of the electrical system and identify any underlying problems. They can also provide recommendations for correcting the issue and ensuring the safety of the electrical system. Remember, safety is always the top priority when working with electrical circuits. Take all necessary precautions to protect yourself from electrical shock and injury. Always turn off the power to the circuit before working on it. Use properly insulated tools and equipment. Follow all applicable electrical codes and regulations. If you are unsure about something, ask for help. Troubleshooting high neutral to ground voltage can be challenging, but by following a systematic approach and taking the necessary precautions, you can identify and resolve the issue. Remember to address grounding issues, check neutral connections, balance loads, inspect for high resistance, assess transient voltages, and consider the possibility of faulty equipment. By carefully examining each of these areas, you can effectively troubleshoot high neutral to ground voltage and ensure the safe and reliable operation of your electrical system.